between circular motion and your gravitational fields. So how does objects or how do objects undergo circular motion due to gravity? So it's a derivation. It's a formal derivation, probably the most common derivation in the entire A2 syllabus. So এটা হয়ে গেলে এটা নিয়ে কাজ করবো আমরা। Just a quick summary of what this is. When your object is undergoing circular motion due to gravity, the centripetal force is provided by the gravitational force. And since the centripetal force is provided by the gravitational force, if you equate these two, your calculation gives you this relationship here. T squared equals to 4 pi squared by gm r cubed. Ekhane hocche 4 pi squared by gm is a constant. So therefore, time period relationship eta. When you're doing your calculation, you'll use this equation here, and this is the relationship. This relationship is partly responsible for the orbit being what in nature? Elliptical, right? So the last question mone hocche dekhai nei, tomake ekটু dekhai. I told you je jokhon oscillation hoy duita jinish kintu oscillate kore. Both the masses oscillate around a common center, right? So eta hocche I think it's a good example. Yeah, do you see how the Earth is going around that star, or that planet is going around the star? But do you see also the star is moving? So this is the reason why orbits become elliptical, because the center starts to move around. And if you're going around the center that's moving around, do you become a perfect circle, or does it become little distorted? So it becomes distorted, as you can see here. So eta jeta hocche je the purple mass and the yellow mass are orbiting a common center. A common center somewhere closer to the yellow mass and further from the purple mass, right? So etar jonno eccentric hoye jacche. Ami jodi massটা কমাই দেই এই ছোট massটা, তাহলে দেখব যে it's not capable of keeping it back in orbit. দুইটাই হচ্ছে উড়ে চলে যাচ্ছে. Do you notice that? That's because the gravitational force is not strong enough to retain the mass in orbit, right? So আবার যদি start করি এখানে আর to mass লাগবে obviously. এই যে এইটাতে যেটা হচ্ছে is still not capable. So yeah, এখন back করা start করবে, but ওরা কিন্তু হচ্ছিল center of mass একটা আছে এখানে, ওইটা চারিদিকে হচ্ছে orbit করতেছে. So you'll notice that the purple one is also doing an orbit, the yellow one is also doing a small orbit. They're doing an orbit around each other. Okay, ওই যে x টা হচ্ছে the center of rotation for both the masses. বুঝছো জিনিসটা? এটার জন্য এটা হচ্ছে elliptical হয়ে যায়. You don't have this in your syllabus. It's very complicated, like the physics. আমাদের জন্য খুব simple. We assume that they're undergoing what motion? Circular motion, perfect circle. তার জন্য তো our formulas and everything work, right? But reality can be different. Okay, so students then ask me that if the orbit is elliptical, right? But math করলে কিন্তু দেখায় that the Earth will take 365 days. মানে the actual value. How is that possible? So ওইটার জন্য there is this interesting math here. Again, not for our syllabus. Elliptical orbit eccentricity বলে একটা animation দেখবা. এই animationটা হচ্ছে should be usually clarified here, this one. Okay, so if you look at this animation here, তুমি নোটিস করবা একটা জিনিস এখানে, and আমি বলবো না, এটা তোমরা নিজেরা ফিগার আউট করার চেষ্টা করো, that why circular motion is fine for doing calculation here. Is let me rephrase my question. My object is not undergoing a circular motion. It is undergoing a what motion? Elliptical motion. But circular motion equations will work, and then the time period that we get will be fine. Okay, despite the orbit not being a perfect circle. So why is that so? So this diagram here kind of gives you an idea. So একটু দেখে figure out করতে পারবা কি হচ্ছে. So আমি একটু তোমাদেরকে বলি কি হচ্ছে এখানে. Do you see that pink color mass? ওটা সবচেয়ে eccentric মানে খুবই elongated, right? And the red color mass is the perfect circle. Now if you look at their movement, কেউ কিন্তু like they're not in sync with each other, but there's a reason behind us choosing circular motion for all of them. ওই reasonটা কি বলতে পারবা? Yes, exactly. So তুমি যদি পার্পলটাকে যে কোনো কালারকে যদি ফলো করো, they actually take the same time to make an orbit. Despite being elliptical, semi-elliptical, elongated, circular, ওদের কিন্তু time period same. And if the time period is same, আমি যদি ম্যাথটা assume করি that the Earth is going around the sun in a circle, our answer will still be the same as if it was going in a what orbit? Elliptical orbit. That's why we can do our math. Do you understand? আবার রিপিট করি, আমরা সার্কুলার মোশন করে অ্যাজাম্পশন করে ম্যাথটা অনলি করতে পারি because the time for a circular orbit and the time for an elliptical orbit is what? Same. Okay, so yes, of course the electrical physics is very complicated, right? But for your introductory gravitational field chapter, we will assume that the orbits are circular and it will be fine because time period to ashbe amader. Okay, so yeah, we have some limitations in the way we do our math, but our time period এগুলা সব normal আসবে, কোনো problem নাই. Okay, so eventually if somebody realizes যে wait a second, orbit তো হচ্ছে straight না, তাহলে it's not a problem, হচ্ছে মানে perfect circle. Circumference, the distance traveled here, same necessary না, কারণ এখানে একটা জিনিস হচ্ছে their speeds are different. You'll notice that the pink one, right, is slow, and একটা পয়েন্টে দেখবা অনেক স্পিড বেড়ে যায়, যে এই জায়গা আসলে it accelerates the fastest. So even if the circumference is not the same, it will still take the same time. So circumference is not necessary to be same. Okay. Again, speed is also not same. Okay, so if your speed is not same, how do you do this in math? Somebody do math correct speed very quick. What speed am I finding? Average. Okay, so it's always average speed that we are finding. Right, so that is what we have done last class. We'll do a couple of maths from here and move on with the chapter. Right, so একটা example দিচ্ছি। এখানে আগে যা বললাম ওটা লিখে রাখি। We assume that the orbit changes. Oh, no, that's obviously over long term. So like our sun, this is the mass of the sun, right? In context of next 100 million years, it wouldn't change enough for us or for our math to change. It is changing every day, but it's not going to be appreciable for any change to be observed with the Earth. Right, we assume that the orbit is circular for calculations justifies since the time taken is the same for circular and or elliptical orbits. Okay, I'll give an example. Aske will see how satellites work. It's part of our syllabus. So before I get to that, let's do a basic math here, okay? Right. Find the distance of the moon from the center of the Earth. Mass of the Earth is provided. Radius of the Earth is provided. Time period of the moon is provided. So the moon takes approximately 28 days to go around the Earth. So moon cycles are 28 days, roughly. So ওইটা হচ্ছে time দেওয়া. So using this information, find how far is the moon. Also, eventually find the velocity. Let me explain. So this formula, this mass is the actual mass that the orbit goes around. So this is the central mass, and the small mass is not here. So that means the object that's actually going in a circle, its mass doesn't matter. Okay, so this is G value to জানো তোমরা I hope. G না জানো বলেছি 6.67 into 10 to the power minus 11 Newton meter square per kg square. It's called the universal gravitational constant. Yeah. Kilometers or meters? How much? That's something like 29 kilometers. 39 kilometers. 10 to the power 3. Yeah, that's it. Sorry. Oh, so it has to be seconds. All the units for time always has to be in SI base, so seconds. Did you convert? সবই convert করা হয়ে গেছে 28 days কে second তে convert করছে আসল কথা নাম্বারটা ঠিক আছে পাওয়ারটা প্রবলেম পাওয়ারটা 10 to the power 8 হওয়ার কথা না ওইটাই হচ্ছে ট্রিকটা এখানে এই ভ্যালুটা ইউজ করা লাগবে না because whenever we do our math is done from center of mass to center of mass so that radius doesn't matter. If the question was how far is the moon from the surface of the earth তাহলে যে অ্যান্সারটা আসবে ওখান থেকে এটা মাইনাস করতে হবে। হ্যাঁ মুনের সেন্টার যদি হয় তাহলে হচ্ছে অ্যান্সার ঠিক, মুনের যদি সার্ফেস হয় তাহলে মুনেরটা মাইনাস করতে হবে। Okay, so Koridei, what should the math be here? So it's pretty straightforward, just substitution here, okay? So t square is equal to 4 pi square r cubed divided by gm. And we want to know the distance, right? So r cubed to be korte hobe. So t hoche 28 days, 28 into 24 into 3600. Which again, 24 for 24 hours into 3600. এটা হচ্ছে square into g 6.67 into 10 to the power minus 11 into mass 6.02 into 10 to the power 24. Right, so divided by 4 pi square, divided by 4 pi square. যেটা আসবে অ্যান্সার ওটাকে তোমরা এটা করবা cube root, right? So এটা করলে যেটা আসে r, that's the answer. কত 3.9 into 10 to the power 8 meters. Okay, 18 answer. Okay, yeah, so that's the answer. And then the question is find the velocity of the moon. So this is the distance, and next how fast is the moon moving? So it's easy hor kotha, it's a completely circular motion question. What is it? Answer. One 161. One zero one two. Okay, so how do we do this? What are the equations of circular motion? One more time. Chatta. So let's start with omega. What's omega? Yeah, 2 pi by 3. V equals to omega r. A equals to omega square r or v square by r, right? And then f just m multiplied by diva. So yeah, in this case, it's going to be v equals to omega r. আমার হচ্ছে দরকার the velocity. So omega is going to be 2 pi by t times radius r. So just এখন ভ্যালু করে বসিয়ে দেই। Time period is going to be 24 into 3600 into 28 into radius is the distance here 3.9 into 10 to the power 8. কত ছিল 1012 meter per second. 13. Right, so this is very standard question. You get plenty of these in your exam. 3 marks হয়, sometimes 4 marks. 4 marks হয় যখন হচ্ছে ইকুয়েশনটা derive করতে বলে না, তোমাদেরকে recall করতে হয়. So you have to recall this equation. And typically the question is actually followed by a derivation. So প্রথমে derivation চাই, তারপর questionগুলো জিজ্ঞেস করে. So you'll always find this derivation first, and then they'll ask you questions based on that. Okay, so সব মিলে এরকম যদি কোনো question আসে এক্সামে, it's like 6 marks, almost guaranteed. The derivation would be like 3 marks, and the math would be like 3 marks. Done. Okay, so it হচ্ছে gravitational field and circular motion. This derivation that you see here is very important. আমাদের হচ্ছে the other thing that we'll go into is this one. This is interesting, page number 7. But আগে তোমাকে বুঝাই নেই. It's satellites. How do satellites work, and what's the physics behind them? So the types of satellites like there. Right. To screen it, let me explain. So first of all, let's try to understand the need for a satellite. So why do we need satellites? Simple question. Satellite can lage. Reflect waves. Yes, but what kind of purpose do they serve? Why do we use them? Huh? Yeah, it's used for communication. Mainly, it's used for communication. It's used for weather forecast. It's used for GPS, right? So you're satellite lage because I'm going to show you something where you need to understand the need for the satellite we're looking for. So satellite একটা থাকে এরকম, and satellite কেমনে launch করা হয়? Like how do you launch satellite? I talked about this last class. So let's say this is a satellite. Do you just send the satellite into space and just keep it there and come back, or do you do something else? Yeah, right. Why is that so? Yeah, so the main premise of what we are doing here is the fact that for objects to be in circular motion, they need to have what? A particular velocity, okay? So তোমার যদি objects হচ্ছে circular motion যায়, ওদের একটা velocity থাকতে হবে, velocity না থাকলে কি করবে? It will come crashing back. So I think I showed that Newton cannon example, যে তোমার যদি হচ্ছে satellite too fast হয়, it'll just fly away, right? If your satellite is too slow, then what will it do? It'll crash. But there's this very particular velocity that you launch করতে পারো, it will be there literally forever. Kono fuel lagbe na kichu lagbe na, it'll just be stuck in that motion, that circular motion, right? So that's how satellites work. So it means that if I want to launch a satellite, I need to what the satellite, send the satellite at a particular speed into orbit, right? And that's what rockets would do. The rockets would fly into space. They will enter the orbit themselves with that velocity. So rocket gulo nijera Earth ke rotate kore. And as the rocket is rotating at a speed, what is the satellite speed inside the rocket? What I mean by that is this is the rocket, right? Rocket or সামনে কিন্তু satellite থাকে. So your rocket এখন হচ্ছে going in an orbit, right? What's the speed of the satellite as well? Same, because according to Newton's first law, if something is moving, every part of it will be moving at the same rate, right? তারপর কি করে ঘুরতে ঘুরতে they separate. And separate করার পরে যেটা হয় rocket আর satellite দুটোই কিন্তু same ভাবে ঘুরতেছে. I mean they're still moving together. Speed is same and everything. At one point, what does the rocket start to do? Move out, yeah, and then comes back down, and the satellite will be stuck there forever. Okay, so that's how satellites are launched. Satellites কিন্তু কোনো navigation, maneuver করার usually কোনো mechanism থাকে না. Once you go and launch it out there, it's there and it just stays there. Modern কিছু satellite থাকে where they have boosters and thrusters that produce some force that can take them where? To a different orbit. So speed বাড়ানো কমানো যায়, okay? But it's very limited because as the fuel runs out, they become dysfunctional. So over the years, we have sent over 40,000 satellites into space, right? Out of that, only 5% now work, and the rest of them are just floating around there. They're called space debris, space junk. Because they're not functioning anymore. Their batteries have run out, their electronics have stopped working, right? So only reason থাকে, they can't now possible now because what don't they have? No mechanism to maneuver. মাঝে মাঝে যেটা হয়, sometimes they start to fall back to Earth. And এটা কেন হয়? They collide with something and that dislodges them from the orbit, right? And they come back crashing into the Earth. So it has happened twice so far. দুইটাই হচ্ছে অনেক বড় স্যাটেলাইট ছিল, okay? But most satellites just stay there forever. They just are roaming around. Eventually, at the point, they may fall back or they may fly away. Most likely fall back. From velocity কমার chance বেশি, okay? So that's my satellite out there. Now, let's say I want to I want to establish a link with my satellite. So এটার জন্য যেটা করা হয়, on Earth you have a tower or a station or like a communication center. যেটা কি করবে, এই satellite কে হচ্ছে wave send করবে. Do you guys remember what waves were sent to satellites? Microwaves, okay? Because radio waves had a problem. Radio waves could not penetrate the ionosphere. So radio waves কিন্তু হচ্ছে space এ যেতে পারে না, okay? Like it's not reliable. Space কিছু যায় though. So this will go to the satellite. Satellite এটাকে নিয়ে কি করবে? এটাকে resend করবে to another part of the Earth. And at that part of the Earth, if you have a station, that station will receive that information. And that's how communications are set up, okay? Now, the gap that you see here, it's massive, okay? Like continent to continent. So it's like one continent as another continent. And that's why we use satellite. Do you understand? Now imagine this is a TV broadcast. TV broadcast, let's say it's like a live football match or something, right? And your satellite is here giving you the broadcast. কিছু delay হয়. Cannot delay হয় because the information takes a little bit of time, right? So কিছু delay থাকবে. Here's the problem though. Is the satellite just standing up in the air there, or is it moving? It's moving, right? Is the Earth still, or is it spinning? Spinning, right? So এখানে Earth spin করতেছে, satellite move করতেছে. Eventually, they don't really stay in sync with each other. দেখা যাচ্ছে স্যাটেলাইট এদিকে চলে যাচ্ছে আর আর্থ অন্যদিকে চলে যাচ্ছে, right? So that doesn't really give you a complete link. But if I want to use the satellite as a mirror, literally in the sky, right? Don't I want the satellite to stay there? Because if the satellite is moving, I won't be able to create that permanent link, right? So ওটার জন্য we need satellites that are stationary up above us, literally, right? So how can you make a satellite stationary? If your satellite is stationary, there's a problem. What will it do? Yeah, it'll crash back to the Earth, right? Satellite to the Earth is stationary, it cannot crash করবে because what's the first and foremost requirement for circular motion? The object has to be moving. If it doesn't move, it will fall, right? So move যদি না করে তাহলে তো পড়ে যাবে. So how do we ensure our satellite stays stationary there? So any ideas? Yeah, বলো কি বলছেন? Same velocity as the Earth. আচ্ছা, okay, that's one option. Same velocity. Maintain what? Yeah, but how do you ensure that? Do you make sure that the satellite and the Earth have the same speed? Right? Is that it? So if you want to maintain position, right? Larger radius, like really far away. But in that case, like so the Earth is a ball like that, right? So wouldn't the Earth go that way? Even though the satellite is moving very slowly, wouldn't the Earth spin so that communication would be broken again, right? Achha, you guys are close, but not velocity. The thing is, it is impossible for you to maintain same rotation if you have same velocity, and this is something we learned in circular motion. Why? We learned that the further you go in a circular motion, all parts have what velocity? Different velocity. And then I told you that the velocity is the least where at the center, and the velocity was the highest where the further you go away, right? So এখানে যদি ওর velocity আর earth velocity same হয় তাহলে তো ও পিছে পড়ে যাবে because it has to cover a very large distance, right? Same velocity to the পারবে না. So the right answer was the online দেখনে. Yes, exactly. We need to make sure that the satellite and the earth have the same time period. Time period same থাকলে কি হবে? এই যে একটু imagine করো, earth হচ্ছে spin করে, এই যে এই পার্টটা spin করে এখানে আসলো in 24 hours. Satellite-টাও spin করে এই জায়গায় আসলো in 24 hours. So wouldn't they be in sync with each other? So these kind of satellites are referred as geostationary satellites. So what are geostationary satellites? Let me explain. Speedetta হচ্ছে তোমার Earth's surface are a satellite, right? If they have same speed, which one covers more distance, the surface of the Earth or the satellite? The satellite. The satellite radius are বড় না? এই যে আমি draw করে দেখে there. This is the circle that the satellite covers. This is the distance that the point on the Earth covers. Which one covers more distance? Satellite, right? So Earth or the satellite speed same থাকে, will the satellite be able to keep up with the Earth's surface? Not so, because it is slow now. Because it has to cover more distance, right? Because Earth এদিকে চলে গেছে, satellite এখন এই জায়গাটায়, because of the speed কম, he wouldn't be able to do the full rotation properly. So we have to ensure what is same, the time period, right? And these satellites are called নামটা বলি নাই, geostationary satellites. So they have one purpose, which is to remain geostationary satellite. These satellites remain stationary above you in the night sky or in the sky, and you can actually see them. I mean, there are apps in your phone where you can point them in the night sky. You can see satellites there. Not actual satellites, but they'll tell you the location out there. These are geostationary. Some of them you can even see using binoculars. So ওগুলা actually সবসময় থাকে, দেখে মনে হবে they're fixed in the sky, right? But they're actually moving with you. So therefore, that illusion is that they're stationary. But what are they actually? They're moving. they're moving at the same rate as the Earth. So at any given point, where are they? Above you, right? So same rate, time period, omega is same. Not V. V same হলে কিন্তু পিছিয়ে যাবে. Okay? So these are called geostationary satellites. এগুলা হচ্ছে the most common satellites out there because they are very good for communication, information transfer, এই জিনিসগুলো. So if you have like a satellite TV in your home, right? ওই যে dish থাকে না ছাদের মধ্যে, that satellite dish, they work in একটা জায়গায় point করে রাখে. If you notice all the satellites that's of the same provider, they're all pointing at the same place. What are they pointing at? A satellite, okay? এই আমাদের বাংলাদেশের যেটা আছে ওইটা হচ্ছে একটা particular angle থাকে, ওই angle point করলে হচ্ছে QVC connection. So it's always going to be there. These are called geostationary orbits, okay? So yeah, this is one kind of satellite that we have. The satellite covers a larger distance, therefore it has to have a higher velocity. Correct. So you can have velocity into same none. Who is faster? Satellite. Because if you want to cover a larger distance in the same time, you have to be faster. Okay. So yeah, this is your geostationary. What is geostationary satellite used for? Duita jinish, communication and broadcast. Which falls under communication as well. Now there's another type of satellite out there which তোমাদের ম্যাথ দিবে না, but এটা আগে ছিল. তোমরা যদি question paper solve করা start করো, you notice there's been a drastic change since 2017. তোমরা কিন্তু paper in your actual exam, you had like section where you had to choose answers, like দুইটা question answer করা হতো out of 5 of them. They were called applied sciences. চারটা subject ছিল. One is called medical physics, one is called communication, then there's something called sensors, and lastly there was one more, radioactivity. So এই চারটার থেকে যেটা করতে হতো, you have to choose one of them, and these are very complicated topics. Complicated কেন? They used to teach you things that even people who operate satellites don't know about. মানে একটু extra detail ছিল. What they did was 2019 they split it up. They didn't get rid of it. It's still there, but they put it into different chapters. So এই satellite যেটা আমরা করতেছি, এটা আগে gravitational fields ছিল না. There was a chapter called satellites. So ওটাকে এখানে নিয়ে আসছে. ওইখানে they used to teach you about geostationary and another type of satellite called the polar satellite. আমি এটা করে রাখতেছি for safety because I don't know if they have got rid of this. কোনো জায়গায় ওরকম information বলা নাই. They did mention satellites that they're in gravitational field chapter, but what type of satellite in particular mentioned করা নাই. So এটা করে রাখি. It's called a polar satellite. So what's a polar satellite? Polar satellite is a satellite that does this, that it goes around the Earth and it covers the Earth and every inch of it. So let me explain why is that good. So let's say you want to do weather forecasting. যে তোমার হচ্ছে weather check করতে চাও. Is it good enough that your satellite just stays in one place all day? No, right? Don't you want to cover the Earth? মানে a weather company কিন্তু covers the Earth. They provide weather services for the Earth, right? Not for one country. So in that case, যেটা করতে হবে, তোমার স্যাটেলাইটকে সব জায়গায় যেতে হবে, and that can be possible if the satellite does an orbit that looks like this. But it basically draws around the Earth, and এই orbitটা যদি maintain করতে পারো, it's considered a polar satellite because it goes over the poles. তার জন্য polar বলে. Question হচ্ছে, what's the main difference in the orbit of a polar satellite and a geostationary satellite? So geostationary satellite is always, and listen very carefully, you have to explain this is always above the equator. So geostationary satellite orbits are always above the equator. They're called equatorial satellites. And they are at one location only. They can move around. So why is it so? Any guess? Why is a geostationary satellite orbit like this? Equator উপরে থাকে খালি, অন্য কোনো জায়গায় যেতে পারে না। কাছাকাছি actually. It's something to do with gravitational force. So if your geostationary satellite, right, is you send into space, ওদের orbit এটা থাকে, that's the geostationary orbit, right? It's equatorial. Equatorial মানে হচ্ছে above the equator. Can you tell me if your satellite is above the equator, which way is the gravity acting on it? Weight, straight downwards like that? Do you agree? আচ্ছা, আমার যদি হচ্ছে স্যাটেলাইটটা এখানে না থেকে একটু উপরে থাকে, like this, like here, which way is gravity acting here? Again towards the what? Center, right? But there's a problem though. I'll show you the problem right now. Right. So এই যে এদিকে unfortunately তোমার স্যাটেলাইট কিন্তু হচ্ছে এভাবে যাচ্ছে. The satellite doesn't orbit that's like this. So if your satellite doesn't orbit that's like this, right? এই যে এরকম দেখতে যদি হয়, can you tell me what provides centripetal force? Gravity কিন্তু হতে পারবে না. তোমরা কি বুঝছো ডায়াগ্রামটা? আমি ডায়াগ্রামটা একটু ক্লারিফাই করি. My satellite is doing this right now. Above the poles. That's why it's called a polar satellite, right? So এটা কি এখানে থাকতে হবে না? So if it's here, right, weight to act করতেছে towards the center of the earth. Our circleটা তো এখানে. So what provides gravitational force? Yes, exactly. This weight that you see here can be broken down into two components. There'll be one component acting this way that will provide my what force? Centripetal force. And there'll be one component acting which way? Downwards. And that will provide a downward force. And the consequence of this downward force is that satellite কি করবে? এভাবে spin করার চেষ্টা করবে, but as it spins, it will also start to what? Fall down. Do you understand? Spiral down করবে. Because if it's fixed and there's only one force towards the center, it will maintain a perfect circle. But imagine there's a force towards the center, but there's also downward force. What's the path it takes? A spiral, right? So it spirals downwards. So এখানে কি করবে স্যাটেলাইটটা? It will go like this, like that, like that. তারপর একটা ইন্টারেস্টিং জিনিস হয়. Once it reaches the other side, যে এদিকে, তখন কিন্তু everything reverses. Because my centripetal force is still acting which way? This way. But that green color arrow will now act which way? Upwards, right? So satellite tower spiral back for a start করবে which way? The other way. So eventually যে pathটা হয় এরকম দেখতে হয়. I will draw and show you. So এইভাবে এদিকে যাবে, এদিকে গিয়ে, and it will start to reverse back which way? Up again. And it'll continue to do this. Meanwhile, the earth is spinning, right? So eventually it starts to cover every inch of it. And that's how GPS, weather forecasting, mapping, সব কাজ করে. So it basically draws around the earth multiple times, right? So yeah, that is how polar satellites work. So polar satellites, their orbit হচ্ছে obviously different, but what are they used for? So they're used for mainly two purposes. একটা হচ্ছে navigation. So when you have like GPS works on polar satellites. আর একটা হচ্ছে weather forecast. Anything else? Mapping, yes, mapping is also correct. Mapping. Now, one last thing before I show you the map related to this. Right, so geostationary satellite, আমাকে a couple of things বলো. আচ্ছা, the geostationary orbit, এই center কেন থাকবে এখন বুঝছো? Because আমার যদি এটা একটু উপরে থাকে, wouldn't there be a component acting downwards, which will take it away from that position? And if it's little on the other side of the equator, wouldn't there be a component acting the other way, which will take it away from the position? So I need to be at a point where there's no what acting on it, vertical component. There's only one force acting on it, which is what? The weight. And that's exactly the force that keeps it in orbit. And this is only possible if you're above the what of the planet? The equator. Acha, because তুমি পোলে থাকলে কেন হবে না বলতে পারবে? Why can't the polar satellite do this? Because পোলসে যদি এভাবে থাকে, ঠিক আছে, স্পিন করতেছে 24 hours but earth তো স্পিন করতেছে অন্যদিকে. So you can't sync. তুমি একদিকে যাচ্ছ, earth আরেকদিকে যাচ্ছে. So the first thing that you need to ensure for geostationary satellite is that they must have same what? Same velocity or same time period? Right, same time period. I mean, like into আলাদা করে লিখতে হবে. I'm just noting them down here. Can you tell me what else has to be same? Direction. আচ্ছা, direction আগে just বলে রাখি, এটা equatorial হতে হবে. Equatorial orbit. What else should be same? Yeah, geostationary. Like geostationary satellite এর জন্য properties আছে কিছু, তিনটা properties. More angular speed. The same কি থাকতে হবে? So they must be same time period, equatorial orbit থাকতে হবে, and there's one more thing that's mandatory. Now this thing doesn't work. It's kind of obvious, but no. Mass এখানে কোনো effect নাই, right? It's the direction. What if your satellite goes one way and the Earth goes the other way? I know it's kind of obvious, but যদি ওটা হয়, will it work? না, তাহলে তো absolutely not possible. You'll probably meet the satellite once every day for a brief amount of time. You're going the other way, right? So we can add a question arise for it. Which way should my satellite spin? In the same direction of the Earth, right? Which is what? Eta চাই ওরা জানতে. Is it west to east or east to west? How does the Earth spin? এটা একটু চিন্তা করে answer করো. It's interesting একটা answer. East to west. Sun rises from the east, right? So which way does the Earth spin? West to east. Okay, how many of you think that the Earth spins east to west? Remember, the sun rises in the east and sets at the west. Okay, so which way does the Earth spin? East to west, Kara? East to west. Acha. And how many of you, rest of you, think it's the other way, west to east, right? It is west to east. It's west to east because, you know, the problem is you have made a great mistake here. You thought the Earth is the thing that's stationary and the sun is the thing that moves around, okay? But it's actually not that. It's the sun stationary and the Earth is moving. So if the sun rises from that side, you're going the other way. So the Earth is going from west to east, so the sun rises from that side. Sure. So yeah, I know it's usually students will go for the movement of the sun in the night, like in the sky, but that's not it. Huh? But that's from the point of view of the Earth. Earth is moving towards the sun. The sun is good to say. By the way, don't get it wrong. The sun still rises to the east there, right? But it's the Earth moving that way. So this is the sun, right? And the Earth goes that way. If you want to cheese, take it right. That's the Earth spinning that way. Okay, so it's west to east. Right, so these are some of the features for your satellite. Just to copy right now, then we'll do math and figure out where does this need to be. But before that, it's a scam. I want to show you a scam here. So it how people get scammed with satellites. Right, so there's a very nice animation here that shows you the geostationary satellites. I mean, I think this is the one. Right, so that's how the geostationary satellite is. It's a little pixelated, but you can see that as it moves around, right, that satellite is always over the same position on the Earth. Okay, and you see the orbit is around the equator. It's right at the halfway line, right? So that's geostationary satellite. But the scam is here. ওইটা I think হচ্ছে axis of rotation কে show করতেছে. So এই যে এরকম দেখতে একটা example দিতে তোমাদেরকে. Have you heard of the rings of Saturn? Yes. Right? Where are those rings? At the like all around Saturn or at a particular location? Yeah, it's at the equator, right? So what happened to the other masses around it? So those crashed. It's only the one at the equator that had the perfect rate and everything. They got stuck in what motion? Circular motion. So yeah. So এই জায়গাটা একটু দেখো. If you look at this is a map. NASA releases it very often. It's a map of all the satellites out there. Very big ones. They classify them in different categories, starting from the size of a basketball, right, to the size of a bus. Basketball is the biggest ones out there. Basketball is one of the smallest ones out there. The first ever satellite called Sputnik 1. It was a basketball, like actual size of a basketball. It just only had like a transmitter that transmitted microwaves. That's it. Okay. And Buster Moton Jiglas Borgolo, those are usually like telescopes. There's something called the Hubble Space Telescope that's actually like very large. And then you have for communication purpose অনেকগুলো থাকে so yeah এরকম দেখতে do you see a particular location that's a little highlighted মানে এখানে কি can you make out the place where the geostationary satellites might be হ্যাঁ ওই যে দেখতে পারো there's a circle pattern that's produced around it right so that's the place where the geostationary satellites are now এটার হচ্ছে অ্যানিমেশনটা দেখালে একটু বেটার হতো আমি খুঁজে পাচ্ছি না I think this okay so the point I was going to make ওইটা বলি this is the one okay yeah this is like you know how satellites are moving right now can you see there's like a traffic around the earth যেটা একটু অ্যাঙ্গেলে দেখা যাচ্ছে right those are what satellites which is do you see there's like a slanted line around the earth yeah polar acha but তোমরা যদি দেখো যে এদিকে like I can't zoom it more but তোমরা কি একদম রাইট সাইডে একটা এজ দেখতে পারো circle যাচ্ছে like can you see the geostationary orbit the geostationary orbit is not the one on the earth it's really far away do you see there's this very large disc-like pattern around the earth right ওই তোমরা রাইট সাইডে মনে হয় বেস্ট দেখতে পারবে I can't bring my mouse here but ওই জায়গাটা দেখা যাচ্ছে okay so the thing that I'm talking about the scam is that if you want to send your satellite to a geostationary orbit right you have to pay rent to a company that has bought it out so back in 1970s somehow they got the legal permission to buy that orbit they own it in space okay it's their land so তুমি যখন geostationary satellite send করতে চাও you have to pay them rent so that's the thing and I don't know how anyone agrees with it but legally they can own it apparently okay so geostationary parking fee থাকে if you want a geostationary satellite you have to pay that company then you can place your satellite there and our parking fee এখন they say the reason why now it's very important is because it's very congested out there there's so many geostationary satellites out there so সবাইকে আলাদা আলাদা location sell করে otherwise there'll be a clash so that's why that company এখন সবাই agree for it like you maintain that space for us so that's you'll find that in the future geostationary satellites would become very limited because the space is actually limited okay and also তোমার location উপর depend করে বাংলাদেশের geostationary location আর ইউরোপের geostationary location আলাদা হবে তো right so there are some places that are very high demand especially the European region so yeah that's what geostationary satellites look like এই জায়গায় নোটিস করবা all those that are going around you can see that big band out there they're all your geostationary satellites okay so yeah this is it our next class I'll give you the notes and everything
stationary gravitational field so it has no energy
just রাখলাম হ্যাঁ
and then it will start moving attracted so energy cannot be created with destroyed so
there is energy কেমনে বলি এই যে তুমি যখন বললে না রাখলা এখানে so whenever you place anything in a gravitational field it possesses an energy it's called
gravitational potential
এখন প্রবলেমটা হচ্ছে তুমি যে জিনিসটা ইমাজিন করছো ওটা করা পসিবল না যেমন জাস্ট এখানে রেখে দেবো তোমাকে কোনো জায়গা থেকে নিয়ে রাখতে হবে ওই যখন নিয়ে রাখতে যাচ্ছে তোমাকে এনার্জি নিয়ে ওইখানে রাখতে হচ্ছে so it's like this ball this pen right now so আমি যদি পেনটাকে ধরে এখানে রাখি আমাকে কি দিতে হচ্ছে এটাকে yeah so তার জন্য এটা এখানে রাখলাম তো ছেড়ে দিলে পড়ে যাচ্ছে so এটা যদি out of nowhere magically এখানে appear করে তাহলে obviously math won't work because you're working with magic right now inshallah দেখি